Okay, let's give you guys some practice. So here we've got a square base pyramid. The height of the pyramid, that's from this bit here, the center here, all the way up here, is h, and the length here is x. Because it's a square base, if this is x, then this must also be x. And the volume of this shape is given by this. So now we're going to keep the height of the pyramid the same. We're going to keep it constant, and we're going to vary x. So x here is it gets bigger or it gets smaller here. Well, we're going to vary x. Now my question is, if we were to vary x, come up with the relationship between volume and x. Could we say volume is proportional to x, or could we say the volume is inversely proportional to x, or is volume inversely proportional to the square of x, or or could it be volume is proportional to the square of x? Well, what is it? So well, come up with the relationship between volume and x here, okay? And also the second part of the question is, what happens to the volume if I were to increase the length by threefold? So instead of a length of x, we're going to have a length of 3x. So this is going to be 3 times well, it's going to be a really, well, remember that the height will be the same. Well, so the first question is find the relationship between the volume and x. So find this well, what's the relationship between volume and x? And also the second question is what happens to the volume when we increase the x by threefold? So it's going to be 3x. The length is 3x. What happens to the volume? Okay, so press pause and have a go. Okay, so here, yeah, so imagine this as being one bubble multiplying another bubble. We are keeping h the same, so we don't really care about h. We are varying x. So take this bubble out here. Okay, so it will look like this. Volume equals h over 3x squared. So here you've got this bubble multiplying with this bubble here. The thing is, we don't care about h. H is always going to be the same. We don't care about the number 3. It's just a constant. It doesn't change. We are just varying x. Okay, so well, because we don't care about anything in here, let's give it a new name. Let's call it k. Okay, so here we've got this here. Now when you are here, you can actually make the statement v is proportional to x squared. So this here is your relationship between, you could actually say the volume of this shape here is proportional to the square of x. Okay, so now once you've got this here, you can answer the second question. What would happen when we increase x by threefold? So hang on, let's look at this here. So this is our old volume here. So currently we've got a pyramid. Well, I can't draw it, but it's going to be something like this. We've got a pyramid where this is x, the height is h. Well, yeah. So so this is x here. So the volume of our old shape here is k x squared. Now let's create a new pyramid where it's going to be, whoops, where it's going to be where this will be 3x, okay, and this is 3x. H is still the same, but we don't really care about it. So now we've got a new pyramid. So now put the 3x into this formula here. Okay, so this is our old here. Okay, so our new formula would be, our new volume, let's call it V new, equals k, and then now we are putting this into the x here. Okay, so it will be 3x brackets. Remember, you have to have the brackets here because you're putting the 3x into the x and then you square it. Okay, so this is a volume. This is our new volume here. This is our new volume here. Let's tidy this up. So it's going to be this, and here from indices, when you have x, y bracket, let's say a here, you imagine that it's x to the power of 1, y to the power of 1. So it's this times this here, and then this times this here. So really this equals x to the power of a, y to the power of a. So we are just doing the same thing here. Imagine it's a 1 here and a 1 here. So it's 2 times the 1 and then 2 times the 1. So basically it will be this. 3 squared and then x squared. So remember, this is the volume of our new of this new shape here. Okay. Now we want to express this in terms of the old volume. Then that will allow us to make comparisons between the new one and the old one. Well, anyway, look at this here. This is our old. Remember, this is our old here. V equals kx squared. Okay, we want to express that in term. We want to express this new one in terms of the old one. So V of new equals well, actually, well, at the moment you've got this. At the moment you've got this thing times this thing times this thing. Let's move this in front. Okay, so it will be this 3 squared kx squared, and so really you've got this thing times this thing here, and you notice that this thing here is our old. This is our old, because look at this. Hang on. Look at this. Our old volume here is V equals kx squared. That's our old volume here. Look at this. Kx squared. This is our old volume here. So now our new volume is 9 times. Hang on. Our new volume is 9 times the old volume here. Okay. So if you increase x. So this is x here. If you increase it by 3-fold, then the volume will increase by 9-fold. Okay, because of this thing here. 3 squared is 9. So here it's saying the new volume here is 9 times the old volume here. So you know it's going to increase by 9-fold. So let's test it out now. Okay, hang on. Let me clear this. Let's test it now. So here. So here we've got, let's just put some figures in there just to test it. Let's say age is 10. It's always 10. This one here is 10. But then you can put any number in here. I chose 4. I don't know why. And then if we remember, we increase its length by 3-fold. So this length here will be 12. So this length also 12. And then start off with your formula here. Okay. Now put the 4 into the x and put the h into here, and do the same over here as well, and then put the h into here. Okay, and then you will have this. Well, basically work out the volume of the small pyramid. Work out the volume of the big pyramid. Well, the volume of the small pyramid is this. The volume of the big pyramid is this. Now, so here you've got your small pyramid here, big pyramid here. Well, you start here, and then this is the big pyramid is your destination. So if you want to know the multiplier, then you would get the volume of the big one divided by the volume of the small one. That will give you your multiplier. By looking at the multiplier, you can actually tell how the volume, the old volume gets to the big volume. Okay, so this here is our new volume. This is our old volume here. If you get the new, well, you start here, and then this is your destination here. So get destination divided by your start. Okay, destination divided by start, and that gives you 9. So that means the multiplier here is 9. So that means, well, if you start here, you would times 9 to get to your destination. So here, so by experimenting, by coming up with by coming up with figures here, you can put it into the formula and actually test that it does indeed increase by 9-fold. The volume increase by 9-fold. Okay.